Let's lower that excellent soul music that's going on. How's the conference so far? Is it good? Thumbs up? You guys learning a lot of great stuff? Yeah, all sorts of thumbs ups. Great. I'm glad you guys are here. 4:30, to talk about F#. F# data services, web, cloud at your fingertips. Kind of a tall order. F# 3.0. My name's Dustin Campbell. I am a senior program manager on the Visual Studio Languages team at Microsoft. These days, I am working on C# and Visual Basic on a project called Roslyn, which some of you might have heard of as called Compiler as a Service. So I work on futures for C# and Visual Basic. And so you might be wondering yourselves, why am I here talking to you about F#? He's not on the F# team. Who is this rogue? And the reality is that I am an F# fan. I love F#. When I joined Microsoft about 4 years ago, I was a C# MVP at the time, and I was interviewing for an F# dev position. So I came in to the interview for this F# dev job. It went so-so. It wasn't a great fit for me. But through the interview loop process, they changed the focus to a program manager position. And so as the C# MVP coming in, interviewing for an F# dev position, I wound up being the person to deliver the Visual Basic IDE for Visual Studio 2010. So I kind of run the gamut. But in my personal projects, my spare time, the things I like to play with when I'm playing with code at home on the weekends, I like to write F#. I've got a lot of GitHub projects that are all F#. So that's why I'm here to talk to you about this. Let me kind of take a poll, because F# talks are kind of cursed by having people at all levels with F#. So how many people here would consider themselves, would self-select as a serious F# application programmer? Maybe you have production code. Nobody. Fantastic. That was the actual person I was scared of in this talk, because I don't have much material for you. Now, how many of you would say, hey, I've gone through the F# tutorials, I've done Hello World, I've written some F# code? Good, good. Roughly about 40% of you. And then how many people are simply curious? What is F#? I want to see it. It's totally alien and foreign to me. Okay, good. I have stuff for you guys. And I have stuff for both of you guys. So that's great. So let's get going here. What we're going to talk about here, because F# is cursed, like I said, as being this kind of language that very few experts in. When we come to conferences, we have to give kind of that introduction, the brief history, and so we'll kind of cover that very quickly. I'll give a primer to F# to show, to kind of get your feet wet with some syntax, because it is very different from your typical curly brace languages or Visual Basic. It's just radically different. We're going to look at some F# 3.0 features to kind of address real-world problems. There's a very big real-world problem that F# 3.0 sets out to try and tackle, and we're going to take a look at that. And then we're going to look at this feature, this very specific feature. We're going to show some demos on this, but it's called F# type providers. Now, I want to set some expectations. The internet here has not been great. And you guys are at a talk. Let me remind you what the name of this talk is. Data Services Web Cloud at your fingertips. So I'm going to set some expectations that things might not be as snappy as I would like them to be. Some demos may not work at all. The cloud may simply be sad today, and that's okay. So I want us to have a good conversation. If that happens, we'll talk through things. Maybe we'll ask some questions, and we can really kind of tear apart and get at the meat of what what I'm trying to show here. Okay. Just to set expectations, though, that that the features that I'm going to show in F# 3.0 are very dependent on connectivity. All right. So what is F#? I'm not actually asking. I don't need a show of hands. F# is a practical, functional first language. It lets you solve complex problems with simple code. Now, what do I mean by some of these words here? I mean, there's some key phrases here. Functional first. That doesn't mean functional only. And how many people are familiar, at least passing, with the notion of functional programming? Okay. F# very much promotes or is geared towards a functional style of programming. It doesn't say that it's a functional only language. just functional first. So you can do object-oriented programming with F#. You can do all the, really any style of programming that you want to set your mind to, you can do with F#, but really it lends itself very well to a functional style of programming. Likewise, and kind of on the other side of that, C#, Visual Basic, C++, they tend to be object-oriented first programming languages. And however, you can do a functional style of programming, right? You have lambda expressions in C# and Visual Basic and lots of language features that lend themselves to functional style, but they're object-oriented first. So what do I mean by simple code? There's some kind of loaded terms here that not everybody might agree on the definitions. But when I say simple code, this is kind of at the heart about what I love about F# and why I spend my weekends writing F#. And that's, I get to write elegant code that simply states an algorithm, right? Literally states the problem, and when I execute that, lo and behold, the solution pops out. And it can be a very complicated problem. That's what I consider to be simple code, something that really takes the essence of the algorithm, concisely states that, and then produces the result. So a little bit of history. So F#'s been around for a while. I got involved with it about 5 years ago before I joined Microsoft. It began at a project, as a project at Microsoft Research in 2002. It's based on a functional language that already existed called OCaml. OCaml is, again, it's based on another language called ML from the 70s. So this kind of core syntax of F# has been around for a while. It's diverged quite a bit from OCaml, so if you're really familiar with OCaml, you'll see pieces of it, but it's very different these days. Is the brainchild, or possibly the love child, of Don Syme. Don is he's a researcher, Microsoft Research in Cambridge, and he was also kind of the person that came to the languages teams way back in the early 2000s and said, hey, we need to talk about putting generics into the CLR. And so he was a key designer of the generic framework that's in .NET from CLR 2.0 on. All right. So F# 2.0, and we called it 2.0 because Don had been putting out releases of this under the 1.0 lifetime for a long time. That became a full-fledged product in Visual Studio 2010. Now, the reason for that was we had a lot of people using it for these kinds of purposes: analytical computing, financial data crunching, investment analysis. And we had companies that were just chomping at the bit that wanted to use this, or that were already putting programs into production with something that wasn't even a product, that was just a research language. And so we agreed to take it and fully support it as a language in Visual Studio. And since then, it's become more popular for these kinds of, especially in these problem domains. It's used in banking, like I said, I mean, insurance, energy, lots of places. So a little bit more kind of about what F# is. First of all, it is a 100% .NET language, fully managed. Okay? In fact, it's written in F#, so the compiler itself is a managed application. And that means it fully interops with any other .NET language. So you can call into .NET libraries and frameworks from F#, anything, or it can be called from other .NET languages. And this is a really important for F# because F# really excels at this area of kind of doing algorithmic programming, computation, crunching, that often we'll find companies that are writing their program logic, their business logic, or those sorts of compute, and putting that in F#, and then writing a C# or a VB front end to that to actually do the UI. Okay, so this is a very important point about F#. And then here's where it really gets kind of different. F# is another thing that I really love about F# is that it really takes static typing to the extreme, so that most of your errors, especially the silly programming mistakes, get caught at compile time. Okay? That's very much an emphasis of F#. So, for example, now just to be clear, I mean, C# is also statically typed, but F# takes it quite a bit further. So, for example, in F# 2.0, there's just a feature called units of measure. And what that is it's essentially taking any floating point value and being able to add a type annotation to it. So I can say, oh, I have this value 2.0, but it's kilograms, right? And so then, now that the type checker and the compiler knows about these type annotations, knows about the types of these floating values, it can ensure that you're not going to mix them up, right? Or you can also define conversions between them that are smart and make sure that the units are reduced properly, right? You can put operators on them. It's a very, very cool feature, but that's the sort of place where F# pushes static typing such that you really catch these kind of silly programming mistakes, right? In F# 3.0, it goes even further. So the type checker now allows you to actually introduce essentially extensions to the type checker in F# through a feature called type providers. So you can actually introduce kind of new types and members on the fly. Right? And we use that to great extent for discovering data sources, for discovering data schemas, and showing those for you in IntelliSense and giving you tooling, code-focused tooling, so that when I do, so for example, if I want to add a reference to Bing Maps, I don't have to go and add a service reference and run a code gen tool or any of that kind of work. I can just simply dot into the Bing Maps service, and it discovers that schema for me. Okay? That's kind of what we're going to look at a little bit later. But first, let's go back to the simplicity thing. So I want to give a couple of concrete examples about this. First of all, there's a kind of a term up there that's I don't know if any of you have seen that before, but it's this idea that functions as values. This is something that's very core to functional programming. And what I mean by that, and what that really means is that, we have lots of values in our programs. We have numbers, we have strings of characters, we have all sorts of values that we pass around as parameters to functions. In a functional programming language, and in a language like F#, functions are also values. So I can pass functions to other functions and allow those other functions to use the past functions in their implementation. This should be nothing new to anybody, even if you're not familiar with functional programming. Visual Studio, C# and VB have delegates. That's been baked in since .NET 1.0. So that's the idea that I can wrap up a function in a delegate and pass it off to another function as a value. F# supports that natively. It doesn't have to wrap it up in some other object. It actually just completely supports that natively. So let's look at a kind of a concrete example. This is an implementation of the Gang of 4 command pattern. Right? Everybody should recognize this, I think. I see a lot of recognition on your faces. There's an abstract base class called rover command. Right? It has an abstract execute method. On the subclasses, the execute methods are overwritten, and that's where the actual logic is placed. So the key point here is that there's gobs of boilerplate. Right? There's tons of boilerplate. Really, there's only 2 lines that matter, and that's the implementations of the execute methods. That's where actually the core logic is. So now, to be fair, I probably wouldn't implement it this way in C#, but I just wanted to show the real command pattern. You would see this a lot in Java, for example, but I probably wouldn't implement it precisely like that. However, in F#, I would do it very differently. So in this case, we have a type called rover command, has a single type constructor called command that takes a function. So you see that rover with the arrow unit? That says unit, not uint, C# guys. That's a function. That's a function that takes rover and returns essentially nothing. Okay, the unit in F# is nothing. It's essentially like void in C#, except it's actually a value that can be returned. Yeah, I know, weird, mind-bending, right? Everything in F# is an expression, and all statements in F# are simply expressions that return unit. So yeah, it's all philosophical and weird. I define my break command just by constructing one of these commands, passing in my function, okay, to actually do the work. So not only is it concise, but it's much clearer where the actual important logic is, right? And notice that those numbers in there also have little units of measure on them, right? So on the rotate method at the very bottom, I'm not just passing in -5.0, I'm passing in -5.0 degrees, okay? So let's look at another piece here, another example. So this is actually pretty simple code. It's literally just taking tuples. So there's a function that does swap, which swaps the elements in a tuple, returns a new tuple. There's one that does rotations. It just returns 3 tuples that rotate all the items. And then there's one that does a reduction, right? Takes a function, actually takes a delegate at the very end, and a tuple, and then it reduces them together. Just applies the function to each item and then adds the results together. It's pretty simple code. However, it's really ugly. I mean, I've gotten used to looking at code like this, and honestly, in Roslyn, we have tons of generic code like this. But whenever I type that double, nested generics, and I type that double angle bracket, I just assume that somewhere in the world somebody's slamming their thumb with a hammer. That just makes me feel awful to look at that. It just feels weak. So in contrast to this, here's how I would write it in F#. Wait to take your picture for this. I'd write it like that. Okay? So what we've got here is we've actually got almost identical signatures. The only one that's a little bit different is reduce at the very bottom. Doesn't take a delegate. It actually uses an F# function. But check it out, I'm not even using types. This is something else that's very important about F#. Well, I'll say that it really relies heavily on its static typing and its type checker to find errors in your code. Its type inference algorithm is enormously sophisticated. Now, by type inference, I mean like C# var. How many people are familiar with C# var? How many people hate it? Just these guys. Okay. There's always a few guys that hate it. That's a pretty limited notion of type inference, right? It's only for local variable types. And honestly, when I'm looking at that C# code on the right, I'd really wished I'd had type inference in a lot of other places, so I didn't have to write those double angle brackets for nested generics. Now, F#, on the other hand, not just local variables, but also parameters, return types, literally almost everything in F# can be type inferred. And what's really amazing about this type inference algorithm, it's not just inferring types, it's also determining that, you know what, I can't determine a type here, but it can be generic. So these functions on the F# side, they're all generic. They all have generic type parameters. So F# will automatically generalize your code as well. So to me, this is beautiful. I love the look of this. All right? It's very pretty. So another piece of the simplicity. F# is declarative. And we've talked about declarative and imperative a lot at Microsoft in the languages, but I want to really drill this point home. Because it's in contrast to imperative. And that's what we're actually all familiar with, really familiar with when we write programs, is imperative programming. So imperative is like this. I go and I order a latte, but there's no menu, right? So instead of actually ordering a latte and saying, give me a latte, please, I go and I say, okay, so here's how you grind the beans. And this is how you compress them down. This is how you make the espresso. Here's how you steam the milk. Here's how you know if you've oversteamed it. Please don't oversteam it. That is imperatively going and ordering a drink, where I actually tell them how to do it step by step. And that's how we're used to programming, right? We're used to saying, okay, if this condition is met, then go over here. Otherwise, loop around this variable. If it's greater than 10, then do this. That's the way we program. We program in an imperative style. In contrast, declarative, instead of saying how, says what. Here's what I want at the end. So I say, give me a latte, and I get a latte. And in fact, it might be a lot nicer latte. Doesn't matter. All I asked for was a latte. I don't care how it gets done. I don't care if there's a little pretty bunny face put on it as well. In programming, you guys, I know, are very familiar with declarative programming. You can think of like basic HTML as a declarative language, where I say, here, I've got some elements. Lay them out for me. Here's some nesting relationships, some paragraphs and some content. I am not going to tell you how to render this line by line, pixel by pixel, right? Some guys will, but basic HTML. I said basic HTML. Another example is SQL, where when I select a row out of a table, I don't have to say what that table is or what its schema looks like. I just say, give me this row, give me this data. And likewise, with C# and Visual Basic, link is also a notion of declarative programming, where I'm saying, you know what? I've got a collection here. Give me the ones out of this in this fashion, transform it this way, filter it in this way. But you're not writing the code that says, okay, now I've got my collection. Now do my for loop, loop through it all, check each one. I don't write that. I say, give me this. I want this to be the result. And when that query executes, it might be in memory. It might be accessing a SQL database. It doesn't matter to me. Right? I just want to get my query, and I want to get my data at the end. So let's get out slides for a bit. We've been in slides for quite a while. I can tell because I need water. Let's look at some code. All right. So first, this is kind of the F# primer portion, where we're just going to kind of look at some syntax. We're not going to dig into the web stuff yet, but I want to make sure that everybody's kind of on the same page. So what I've got here, this is actually the F# interactive window. This is a key part of the F# experience. It's a window where I can type code or I can evaluate code. So for example, I could declare a variable x set to 0. And I can build up context in here. It's a REPL environment, which means read eval print loop. It's boldly marching into the 1960s. We've had this for years. Most of you probably remember this from Scheme or Python or anything else. F# also has one of these. And it's very useful, especially for, if I'm evaluating, because I can just evaluate from the editor. Now this expression right here is a list expression. It's a F# list type that contains the numbers 0 to 25, just like you would expect it to be, just reading it. So I can evaluate this in the REPL by saying execute and interactive. From here on out, I'll just press Alt-Enter, the shortcut, but I can evaluate this and see it there. Now that's not really all that great. Evaluating the REPL is kind of like not very good for your eyes. So I've got a file here that'll bring up a WPF data grid and kind of dynamically load that data in there. So when I evaluate this, we should see a data grid with our 0 to 25. All right, this will help us visualize some of this stuff. Now, this is just a very, very simple list expression. You can put arbitrarily complex expressions inside those two square brackets. Those square brackets mean this is a list. So if I come down here, we'll see, for example, this time I've got a list expression that loops through 0 to 25 and returns a tuple. Those parentheses are the tuple syntax with I and then it's square. Okay, so if I evaluate this, we see that show up. Now, that's all well and good, but let's take a look at, I mentioned let a little bit ago, and we're going to talk about let a little bit more in a moment. That's one of the most important keywords in the language. It's one of the most important language features. Another one of the most important language features, probably the other most important language feature, is the pipe operator. And the pipe operator, if you're familiar with PowerShell, with Unix, it's the idea that I can take the output of one command and pipe it into the next one. Okay, pipe it as an input into the very next one. And so it allows us to write our code in F# in the way that it's actually going to be evaluated. So for example, down here, here this is something we might see in math or in our normal code, where you see, okay, I'm calling the function f, but I'm going to pass to it the result of calling the function g with x, right? And so I look at it, and my mind has to kind of turn it inside out to see, which gets evaluated first. So really, what I'd like to see is this: take x, pipe it into g, and then pipe that into f. Okay, so that's the pipe operator. And it's very, very powerful for doing calculations with F#. So here's our same 0 to 25 list. Here's a filter function. And what this does is it takes the lambda that I'm passing in, and this is a lambda. Remember, here's that arrow, and that arrow really denotes it's a function that I'm passing in. I take that function, and I call it for each one of these, and I return a list that filters out all of the i's where mod 2 is equal to 0. So actually, no, sorry, leaves those. It filters out all the odd numbers. And then we pipe that into list.map. Now the job of map is to take a list, a transformation function, call it on every item in the list. It's sort of like link select. Okay? And then we can pipe that into show grid. So now I get the squares of the even numbers. All right? These are kind of toy examples. So let's head over here. This is something a little bit more fun. How many people are familiar with Project Euler? A few people. It's a fun diversion. It's a website of it's projecteuler.net. It's a website of essentially of math problems, some of which are very easy to solve, and some of which are enormously complicated to solve. That if you brute force them, they would take millennia to solve. And so it's a really fun kind of, I think of it as a fitness website for programmers, right? You go and you work out. You're like, okay, well, if it's going to take millennia, what's the cool little number theory trick or algorithm that's going to make this go instantly, right? And so I actually solve these problems with my wife on date night. I know we're totally weird. In F#, she's not a programmer, but because F#, we're able to just state the problem and then kind of get the solution to pop out at the end, she's able to engage and help along. She has a great time with it. So this is Project Euler problem number 6, and we're going to solve it. Actually, I'm probably not going to show you the solution because that would be giving you an unfair advantage on Project Euler, but you might as well have had the solution. So the problem is that the sum of the squares of the first 10 natural numbers is, this. We take all the numbers from 1 to 10 and we square them, add them up, and we get 385. Now the square of the sum of the first 10 natural numbers, so when we add them all together and square that, that is 3025. Hence, and so the whole point of this problem is to make you like tongue twist and try and figure, screw up which is sum of squares and square of sums. Hence, the difference between the sum of the squares of the first 10 natural numbers and the square of the sum is 3025 minus 385, which is 2640. So the problem then is to find the difference between that same calculation, but do it for the numbers from 1 to 100. Okay? So since we've got some values here, let's go ahead and just try and do this with the ones they give us and make sure we get it right. So I'm going to go ahead and reset this interactive session, just so we have a kind of a fresh palette to execute from. And let's do the second one first. It's going to work out nicely that way. So if I wanted to get the square of the sum of the first 10 natural numbers, well, first I need to get the sum, right? So I'm going to call list.sum. This is all using stuff you just saw. Okay? And I'm going to multiply it times list.sum from 1 to 10. And when we evaluate that, we see that indeed it's 3025. Hey, we got something right. Okay? Now, I want to do the first part, get the sum of the squares of the first 10 numbers. So how would I do that? Well, again, I'm going to use list.sum, but I need to square every element, right? And we did that earlier. We squared every element by calling list.map, right? We did that in the sequences part right here. So we'll do something very similar. So I'm going to call list.sum. I'm going to pass into that the result of calling list.map. I'm going to pass a function here, and that function is simply going to square. And it's going to take 1 to 10. And that's it. Okay, that's 385. It's all right. So now, the difference of that looks like this, right? Hey, that's the problem. If I really wanted to solve the problem now, I could put 100s where all the 10s are. But this isn't good enough for me. Like I said earlier, I like elegance and beauty. I really like that F# lets me do that. So let's do a little bit of refactoring, functional refactoring. So this should be fun. Okay? So the first thing we're going to do is we're going to take that list.sum. I kind of want to just get the list out of there. So we'll just come up here and say let. And remember I said that let is one of the most important kind of keywords, language concepts in the F# language. The idea behind let is that it takes a value on the right and it binds it to a name. It's actually an immutable value. It can't be changed afterwards. The value itself could change if it were mutable. But the binding can't be changed. So on the right side of this, I'm going to say, well, we're going to say bind list.sum, the function list.sum, because functions are values, to the name sum. And I can come down here and just delete these guys. Voila. Okay. Notice that the interactive window is showing me the actual signature of this, which is a function that takes an int list and returns an int. Okay? And then finally, my result here. All right, next up. Well, there's this anonymous function here. We might as well pull that out as well. So I'm kind of doing like an introduce explaining variable, I guess. I'm going to create a let binding for that. Now, as I said, functions are values, so that's totally fine to be on the right. There's a more succinct syntax for this in F#. That is totally equivalent to this. However, the idea is that when I bind, if it's going to be a function on the right, I can actually put my parameters here, and then I can remove the anonymous guy. So this is where I'm using let to define a function. Okay, that takes x and returns x times x. Oh, also notice that I can use this in two places, right? Because the first thing I do is square these, so I can get rid of that, get rid of the second one, right here. Okay. All right, it's looking better already. Let's take out this piece. I want to kind of get this is something I should also extract into its own variable. We're going to call it squares. Right now, it takes 1 to 10, but we should probably parameterize that. So I'll go ahead and parameterize it like so. Okay? And then I can simply call squares with 1 to 10. Did you follow that? So now it's starting to look like the problem statement. The square of the sum of 1 to 10 minus the sum of the squares of 1 to 10. Let's go a little bit further. All right? I really want to tear this one apart for you guys. I totally love this. This is so much fun. So let's generalize what's actually happening there. What's really happening is we've got these two lists, and they're the same list, right? 1 to 10. We're applying a function to them, and then we're taking the difference. Can I encode that into a function itself? Well, let's do that. We'll call it difference. It's going to take a function, a second function, and a list. And so what we do here is we apply the first function to the list and subtract that, and subtract from that applying the second function to the same list. Okay, so now we have a function that kind of generalizes that concept. It actually turns out to be a little weird to call, so you're going to have to bear with me for a second because I've got these. I don't just have one function to pass in there. I have two functions. I have this nested square and sum is being passed in. So I actually need to use an anonymous a lambda expression here to pass that in. So this is going to look bad for a sec. Sorry. We're going to do the same thing over here. And then, at the very end, pass in our list. Okay? So it doesn't look as good as it did before, and that makes me sad. It makes me very sad, because I was like all having fun and everything. But it still works. That's great. So let's make me happy. And the way to make me happy is to remember that F# is functional first, and that means that functions as values, you can transform them, you can manipulate them, you can do really cool things with them. And because what we're doing here is something similar to what we saw before, where we did, where the pipe operator, where I had G, and I was passing in calling F, and I passed in X to that. And the idea here is that we could compose these functions together to make one function. Because all we do is pass a parameter to one of them, and then we get the result of the last one. That's all we care about. So we could compose them into a single function. Think of it like this, where I have two functions, one called F, and then if I have, say, G of F of X, I could compose those together by declaring a new function that takes X, right? And just kind of wraps around that. F# has syntax for composing functions together, okay? And that allows us to get rid of a bunch of this boilerplate around here. So instead of calling them like this with the lambda where I'm passing in the list, instead I compose together square of sum with this, what looks like shift left. It has nothing to do with binary operations. And I get back, the result of that is a function that takes the input of sum and returns the output of square. Okay? So I'll do the same thing over here. And that's tasty. I like that. So now we're really getting to the place where we're stating the problem, right? Where I'm saying, okay, now I've got the difference of the square of the sum of the squares of 1 to 10. So, cool. We can use our pipe operator. We can make this a little better, right? We can move this to the front. Because the pipe operator, the way it works is it takes what you're passing on the left and it passes it as the last parameter to the function on the right. Okay, so that will work as well. And I can execute that to show that it does. But this difference function is totally contrived, right? It's like, really? So I don't want to say the word difference in my code. I want to use an operator. I want to use a minus operator. So let's go ahead and let's declare our own operator, our own infix operator with our own characters. We'll just make something up. It sort of looks like a minus. And so now I can remove this, and I can use it infix. And now I've almost declared my own little DSL for solving this problem. Check it out. It still works, right? So if I wanted to actually show you what Project Euler is asking, I would do that. And I will not evaluate that. That is left as an exercise to the listener. Okay? Is that cool? I mean, it's just like, it's kind of mind-bending, kind of twisty, but Really, it is elegant and it's beautiful, and that's what I love about it. All right, let's get back to, get over here, get back to some slides. Because I want to get into the other thing we've been talking about, that we're supposed to be talking about in here, and that's the web stuff. And so what about real-world tasks? There's this problem that I alluded to earlier that I said F# 3.0 is really going to try and tackle. And I need to prove to you that that's a problem and that we have at least, a good shot at a solution, something I think really works. So F# 3.0 has features in it that kind of align around an idea we call information-rich programming. So let me explain what that means. I have two propositions. I do not think they will be uncontroversial to this room. Okay? The first proposition is that we live in an information society. How many people believe that? Good. Okay, I was going to say no hands. Like, have you been on Twitter lately? I can literally go and mine what everybody had for breakfast today on Twitter. I mean, really today, the very random thoughts of people are encoded as information, as data, and is available for us to use for compute, and is being used for compute. It's an incredible place we live in the last 10 years. Now, proposition 2 is that our languages are information sparse. Now, that is by design. These are general-purpose programming languages. Languages do not have to have Facebook encoded in them. I do not need to know C# or F# VB. Do not need to know about friends and status updates and relationship status and whether those relationships are complicated. That's not necessary. However, it does cause a problem because there is so much information in the world, so many schemas, that when we go to attack a new schema, when we try and use a new schema in our program, we have to like relearn some whole new thing, right? It's like relearning how to drive your car all over again. Okay, and so we would in F#, we're hoping to take language support and language syntax to try and help us solve that problem. All right, similar to the way that LINQ solves a problem of data query over disparate kinds of data sources. We want to solve the problem of schema. So there are a lot of challenges here, right? There's this impedance mismatch with statically typed languages. So I could use a code gen tool, right, for a data schema, and that works really well. Add service references to a code gen tool, but then I need to manually make sure I integrate that with the build process, with source control, with everything. And then if the schema changes, there's not really an elegant way to solve that. I have to go and make sure that I run the tool again. Everybody's done this, I think. I'm seeing some nods like, yes, hate this. I get it. It can get even worse, right? If the schema is such that I can't even use the schema properly, I can't generate code. I get like a loss of type information, which is kind of weird. So I'll have to like do like string parsing and that sort of thing, which is unfortunate because these schemas have a crazy amount of rich type information in them, right? They often just have all this information defining that data, and really our statically typed languages should be an advantage to use this, right? Not the other way around. Now, code-gen tools are an interesting kind of solution to this problem where we're taking a schema and generating source code that we can then compile against. But really, we should have a language-based solution for this. We shouldn't have to go and generate more source code. And what I'm going to show in a moment is that that's not always even a viable solution. So the reason this matters, today programming the web looks kind of like this. Okay? This is a graph showing roughly, approximately, the APIs that have been introduced in the last 10 years. So all the way on the far left, you've got eBay. Yay, eBay was first, right? And Amazon. And then on the right, we have all of these well-established companies, right? MasterCard, American Express, I think like New York Times is in there. This is just becoming, it's just increasing the number of APIs that we need to consume in order to absorb this data in our programs, right? And so what that means to you is that when it comes time to write a new program against some new data source, you now need to learn a new API. And that kind of stinks because that means you're not going to get your job done as well as you could have done. So, F# type providers. You can think of F# type providers. I like to think of it as IntelliSense for data. IntelliSense, it's the power of dot. And really, when I say data here, I mean the schemas. It's the idea that I don't need to go add a service reference. I can just put a URL in my code, type dot, and all of a sudden see the richness of that schema show up as types and members in my language, getting the same static typing that F# will give me, the type checker will give me. So let's just take a look. I know I'm kind of, it's hard to think about abstractly, so let's look at something a little bit more concrete. And again, here is the point at which I will say again, these demos rely upon connectivity. Okay? So, be gentle with your evals. So what I've got here is I'm going to look at, actually, let's go back to slides for 1 second. I just want to get a sense of what we're going to look at. We're going to look at Freebase. Freebase is a web-edited graph database that is just enormous. More than 22 million entries in this thing. You can think of it as Wikipedia with a schema. This is the sort of thing that when given to a CodeGen tool, the CodeGen tool goes, this is like really big scale. I don't know what to do with this, right? Because now you're generating megabytes of source code files because there's so much schema there. And it's changing all the time, right? It's changing as people update it and edit it all the time. And so you can see, you could do some amazing things in here, and you can make some amazing inferences. Like you see at the bottom in yellow, there's Steve Wozniak, Woz. You just take 2 hops up, and you get up to Academy Awards through Gregory Peck, right, from alumni of UC Berkeley. It's kind of crazy how you can make these connections with this data. But it is large, very, very large. Okay, so let's go ahead and take a look at it. Now, what I have here, I have a file that actually loads this. So this top line simply loads in the same data grid component we were using a little bit ago, okay, to demonstrate data to you. So that's not important. The second line is important. And this is a #R. In an F# script file or in the F# interactive window, the F# REPL, #R means to add a reference to an assembly. Okay, so I'm adding a reference to a sample that we have, that contains a type provider for Freebase. Now, a type provider is in itself simply a type. It implements an interface, has about 5 methods on it that you can implement and return types and members and those sorts of things for the type checker. And those also come back at design time. Okay, so when I'm editing code. This is actually the type that I'm accessing. I'm putting a little type alias here. Just call it web data. So really, I could call samples.datastore.freebase.freebase data, and you could watch me type that every time, but I'm just going to call it web data. Okay? So let's see how the internet's doing. See if the cloud is sad. So I'm going to type web data, and what you've seen is that it just hit the internet, and it downloaded the schema of Freebase. Okay? At least the first bit here. And so I'm getting IntelliSense. I'm getting quick info tips, bringing down the documentation, telling me how I can use this. And this has got, like I said, it's like Wikipedia with a schema, right? So it's got totally random things in it, which is going to be, could be actually a lot of fun. So I was thinking earlier, I was like, what should I actually show? Let's look at celebrities. Okay, celebrities is something that I know nothing about. Honestly, I couldn't care less. You go to the dentist, you see those magazines about the celebrities. I don't read them. I let them go. So I figure, if I dot into this, I'm going to see like what movies they've been in, why they're famous, what they've done in their lives. But instead, remember, this is world edited, and it's mostly world edited by nerds. And this is what nerds cared about. Okay? And so we see what drugs they're addicted to. We see what crimes they committed, what rehab facilities they recuperated from those drug addictions. And I see this thing at the bottom, super couple. And I don't know what that is, right? I'm just here browsing around a database, a crazy large database. And I see this thing called supercouple, but I can learn from my IntelliSense what a supercouple is. I can actually be taught popular culture by IntelliSense. So a supercouple is a celebrity supercouple, also known as a power couple or a dynamic duo, is a popular or financially wealthy pairing that captivates and intrigues its observers beyond normal expectations. Wow. What the hell? All right. So let's go ahead and pop in here. I'm going to just go ahead and let's just show this in a grid. Since I'm feeling lucky. Let's see what this brings up. So I'm going to Alt-Enter and evaluate that. Should bring us up a data grid. And here it is pulling down information. So, okay, so now I see what a supercouple, there's Benifer. Let's see. Oh, gosh. Some of these I don't know. And there's a little bit of a lag here because it starts downloading images, and that's actually happens synchronously. So we might not get very far with this. That's okay. That's okay. But at the bottom, you'd see like Brangelina, Tomcat, all of these others. Yeah, oh, here comes some. Ike and Tina Turner. Yeah, there's Tomcat. And Brangelina. So that's a super couple, right? I have totally learned something absolutely useless, right, from my IntelliSense. Okay, but this is something that CodeGen would fall down on, right? This is a huge scale, right, to be getting schema from. All right, let's try another one. That was kind of fun. You guys got some giggles out of it. I'm cool with that. This one, remember this is a nerd-edited database, right? I said earlier. So it's not surprising that if I dig in here to, say, fictional universes, that we're going to find this enormously detailed. The schema in here is incredible, right? It's ridiculous. In fact, look, my IntelliSense is telling me, welcome. Welcome to the fictional universe domain. So go ahead and accept this. Hit dot again, and you can see that it's ridiculous, right? It's just got tons of stuff. I can learn about fictional objects, right? I can learn what destroys them and who destroyed them. It's crazy. So let's just dig in and let's you know what? Let's do something similar here. Let's take the actual fictional universes and let's show them in a grid. Before I do, I want to point out one thing here, and that's these backticks. This is a feature that existed in F# before F# 3.0, but it allows you to take an identifier that actually has characters that are non-identifier characters and escape those. So I can have spaces in here, which is absolutely necessary for some of these schemas. We have to do we either have to do some replacement, like say, replace spaces with underscores, or we can do something like this and actually use the real schema column names. All right, let's show it. So, oh yes, Buffyverse. Some of my favorites at the top, the Whoniverse. Anybody Doctor Who fans in here? Just me. Nope? Okay. And I start looking through this, and I'm just like, man, these guys have way too much time on their hands, right? Working out of their parents' basements. It's kind of ridiculous. There's stuff in here I've never heard of, and I'm a super nerdy guy, right? So that's cool and all. Now we're having fun. But let's go down here. I want to actually solve a problem. I would say, like, okay, based on this database and the entries in there, who has created the most popular fictional universe? Okay, and so, in other words, like, how many works have actually been produced for their fictional universe, not necessarily by them, right? And so I can do that down here using the same sorts of primitives, language primitives that we've been using already, right? Using these combinators and anonymous functions. Here's map. Now seek, right here you see seq. That's kind of like list, right? It's actually an IEnumerable. It's just a type alias for IEnumerable. So these are operations that operate on IEnumerable. So you can think of this even more like LINQ than when I was using the F# lists. But we're going to say take this fictional universe creator, and we're going to map over it, passing in a function to say, give me the creator name, comma, so that denotes that it's going to be a tuple. So we're going to create a tuple where the first part is the creator name. And then we're going to count all of the creator's fictional universes and collect all of the works that have been set there, and then kind of count that all up. Okay? So let's run this. Lo and behold, we have some cool stuff here. I'm sure many of you recognize a lot of these names. George Lucas wins, at least according to this database. I think this is actually edited not just by nerds, but specifically by Star Wars nerds, because I know there's a lot more Star Trek fiction out there than 172. I think Shatner has ghostwritten that many himself. So, real quickly, I want to show also, this is equivalent code to what I just did, but using F# 3.0's query syntax. F# 3.0 is not just about type providers, but remember I said it's a set of language features that really are about accessing, getting at data schemas. And so as part of F# 3.0, we've introduced query syntax. What's kind of cool about F# is because F# is this functional language that's very good at generalizing concepts and algorithms, it's actually implemented as a library on an existing F# feature called computation expressions. It's the same feature we built async, F# async on top of. But I can do the very same thing using LINQ and F# query expressions as well and get the same result. Okay? I can't believe this demo worked. That's great. That means the next demo has hope. Okay. Let's flip back over. So, by the way, I wanted to show this. This is the code you would essentially have to write. And this is F# code. And I said F#'s brief. This would be crazy in C# or VB. That you would have to write to access Freebase to get the boiling point and the atomic mass of a chemical element. Okay? This is how hard it is to actually write that code to access Freebase. The type provider encapsulates all of this for you and bakes it right into the kind of plugs it right into the F# compiler, right into the type checker. All right, I'm going to take that away because it upsets me to look at. Really, it upsets me. It's terrifying. All right. So what do we see? We saw that we can program against web scale schematized data. Okay, so something where a CodeGen tool would, like I said, would just fall over. We didn't have to wait for CodeGen or compilation. We were able to just, by the power of the dot, see the next piece, right? Just keep on dotting into that schema and looking at the data, and then also doing computation on it. So we got type checking, which means we can detect schema changes. So if I had IntelliSense up and I was running that demo, and you, sir, what's your name? Yomas? Suppose Yomas had like write access, commit access to the Freebase, system. He could change my IntelliSense list, sitting right there. It's literally happening as we are doing this. So if he changed that schema and F# refreshed, you would see errors all automatically, just all at once. You would see squiggles in the editor as the type checker went through and said, hey, that doesn't exist, or has changed names or something. So, but the key part here is that it has great Visual Studio tooling. When I do development, I don't like to go run tools. I like to stay in the editor. I like to be in the editor and stay focused on my code, focused on my problem. And so we've really gone after that experience, that code-focused editing experience. All right. Let's look at another one. That was fun. I got the laughs. This one's not nearly as funny. Just going to, again, setting expectations. But what I want to do with this one, actually, keep forgetting I have an example of what this is going to be. We're going to take a look at building a website that, given some set of data, would tell me where I should live in the Seattle area. Okay? Sorry, not the entire world. We could do that. It would take time. The internet is slow. The cloud is sad today. But to say, in the Seattle area, in King County, in Washington State, given my age, annual income, household size, work address, and my maximum driving distance, where should I live at? Okay. Now, I plugged in some numbers at one point, and I got back, hey, you should live on Mercer Island, which is a very affluent area. It's got, high household income per capita. But that's the idea. I want to be able to enter this information in and get this answer back. Okay, so that's going to require a few things. That's going to require us to do some demographic information. We're going to need to understand some census data, what the average annual income is in this specific area. We should use cloud for that. It's going to require us to figure out driving distance. It would be really lame if I just did like point-to-point distance. That would be super lame. We should really do driving to distance, right? And so we should use Bing Maps for that. And there's another piece we'll take a look at in a little bit that I would like to do with this as well. So let's flip back here. Now, what I have here is an MVC3 app written in C# that has referenced a F# library that I also have in my solution. So right here, the references are fslib, that's the library I wrote. It also references F# core, so it can use the types defined therein that are kind of F# core types. And then here's my library, and this is where I kind of put all my logic. Okay, so I've got the MVC app, and its job right here, the controller, is it literally is calling into the F# code. Remember, this is 100% .NET language, totally fully interoperable with existing languages. Okay. Now, this is the piece where I want to get some demographics. And you can see right now that I've got a type provider I'm going to try and use, this OData service, but it doesn't have a URL attached to it. And so F# is saying, dude, I don't know what any of this is. Here's all your error squiggles. So it doesn't know what service types is or any of these because I've got the type provider there, but I actually haven't given the input where to go look. So where to go look? Let's head over to the Azure Marketplace, Azure Data Marketplace. This is not super well known yet, but this is a place where you could, it's growing with a number of data sources, but imagine if you can go and literally find data sources, subscribe to them, and then use them in your applications. Okay? So I'm looking for demographic data, so I'm going to search for census. Not too shabby. Internet's doing okay. And I see right here, hey, there's 2010 key U.S. demographics by zip. Okay, as a trial, so I don't have to pay for it right here on the spot with my Amex. That's fine. Now, if I were doing this normally, if I were writing an application that didn't take advantage of F# type providers, I would come down here. I would go to details. I would see, okay, here's my service URL, and then I would come over here, and I would look at this page, and I would read this page. Ugh. Right, I would figure out what tool to run, come back here, find some column names to figure out, okay, what are the pieces of data I need? None of you will remember what any of those were, I'm sure, right? So you won't remember them a few seconds later, but you won't need to, because if I take this URL and I paste it into my F# code using the type provider, I get that for free from IntelliSense. So come in here, we'll paste our URL, and now, give it a second, squiggles go away. Just download the schema. Well, I see some faces that are like, ah, cool. It is cool. This is super cool stuff. So now I can come in and I can say, I can look at the quick info on these, and it comes back with information from the schema that tells me how to use it. So you notice at the very bottom of this it says, hey, you may need to set the credentials property on this instance. Okay, that's fine. Come over here to get data context. It says, get a simplified data context for this OData service. By default, no credentials are set. So I know the next thing I need to do down here is set my credentials. Okay? It actually teaches me how to use it. So we'll come down and we'll look at this code. Now here's where I'm going to do my query, where I'm going to use, again, F# query syntax to search for the demographics that are Washington State and King County. I'm kind of baking that into my application for kind of kicks. But because I've got F# type providers, I get those column names on dot, right? So say state name, which nobody remembered. Though you probably could guess that one. County name. And there we go. So now, if I run this application, I'll just go ahead and build and get the build going. If I run this application, it should work. It may be super slow, because we have these internet connectivity problems, and it's doing quite a bit of compute. But even my local host is slow. Oh, man, that's bad. All right, so here's the application. So let's put in some demographics. What age should I put in here? And bear in mind that if we put ridiculous data, the algorithm tends to fall down because it's not that fancy. So age. What should I put in? 35? 45? What was that? 35. Close to my own age. Not really. I'm like 23 or something, right? Annual income. This will be in US dollars, not in euros. I'd say, well, like $70,000 or something like that. Something kind of average. Household size. 3. Work address. Now, again, because I'm baking this into the Seattle area, I'm just going to put it in the most obvious address in the universe. 1 Microsoft Way. That's the zip code for Redmond. By the way, while I put this in here, I want to kind of walk back. Because we're going to put in driving distance. Let's actually walk back and look at the code for doing the driving distance. The idea here is that, oh, this is actually squiggling. Why is that squiggling? I have no idea why it's squiggling. The internet is slow today. But we're using the Bing Maps API to walk through and get coordinates, build up a route service. This is very similar code that you would write in C#. It's about half as long because it's more brief in F#. It's more concise. We can come down here and ignoring the squiggles, and though these might not work because of the squiggles, yeah. So the squiggles are there. I have no idea why. When I dotted into that initially, I saw the methods that would tell me, how do I use this service? Well, here's calculate route. Here's calculate route async. Here's calculate route from major roads. And it was just like all the methods were available to me there with documentation. It was fantastic. And so I was able to actually just get driving distance using Bing Maps. So let's give it a maximum driving distance to work of like 5 miles. All right, and we'll run this, and this is probably going to take a little bit, is my guess. It's got to grab. But what is important about this Bing Maps piece? So I'm going to walk back here again. Please do not just ignore the squiggles, but look at what this, ignoring that squiggle, what it looks like. This looks almost identical to the OData service earlier, right? Where I've got this uniform way in a type provider to ask for data. This one is a WSDL service. We also have one that's a SQL data provider service. But I can access these kind of disparate kinds of data sources with different sorts of schemas using a uniform manner. That's kind of cool. All right, let's see where we get to. Oh, I see where I should live. We're back to Mercer Island again. I put in too much money. It's kind of funny where the median age is 48.1. So I'd be a youngin' there. What's interesting is what kind of information the demographics gives back to you. Apparently, it's very educated there. Here's the percentage of population with a bachelor's degree or higher, right? It's just kind of funny. So let's go back over here. Now these are just all squiggling. That's okay. That's totally okay. Because I'm already running the app, right? I got it to build and it ran, so I know it works, right? What I've done here is I just want to add a little bit of extra flair to this application. And so I thought, well, now that we've got, where you should live, we should actually show some businesses around there that would interest you. So the idea being that I could come in here and say, go to the Bing search, which is very similar to Bing Maps URLs, but it's actually the Bing search service. Do a search for businesses in that area, and then filter them based on categories using kind of an age, using like an age. So I don't know if this will actually work because of the squiggles. We'll see. Is it working? Nah. Yes. Ooh, it may have worked. So yeah. So for example, as a 20-something, here are the sorts of things I might be interested in, right? It's going to show me, movies, restaurants, groceries, of course, taverns and bars because I'm a 20-something. That's something I'm into. Billiard parlors, so pool halls. But if I come down here and I'm working, like maybe I'm at Bainbridge Island, and I'm 60 years old, well then I might want something completely different, right? And so this, by the way, this algorithm on like what the person wants based on their age is totally mine. It's like just based on my own, my own thoughts about what it means to be 20 or 60. So this one has country clubs and theaters, but no taverns and bars, right? Because you're 60 now. So we actually show that also. Use the same chunk of code in our demo over here. We can see the nearby businesses because we said we were 35. We said, hey, you know what? I'm interested in clubs. I'm interested in taverns and bars. That's fine. If I'd said 45, it would not show those. I'm pretty sure the cutoff date is 40 on that. All right. Oops. So, in summary, what we just saw is that you can program against multiple data sources, different sorts of data sources, using type providers, kind of in a uniform way. All right. You can access web services, databases, all using a uniform interface. If someday we actually have a talk for real F# experts, maybe I'll actually do the F# type provider talk where I show you how to write one. Because you can do crazy things. You can do anything with them. It's just returning types and members given some input, right? So you can do some pretty interesting things with them. We've written type providers that there's somebody that was working on a type provider that just dotted through Facebook, right, through friends and relationships and that sort of thing. It was like, so if you unfriended me, it would just, my programmer would no longer compile. There was a type provider written to dot through XAML files, so it would actually show the structure of the XAML, which is just pretty kind of a cool sort of thing. And the other key part about this application I want to point out is that the MVC app, all that web goo was done in C#, right? But F# worked really well for the program logic, the core guts of the application. So, kind of in summary about what we've been talking about so far in this talk. F Sharp 3.0, right? Tools matter. Tools are very, very important. The fact that I can stay in my editor and manipulate data and do all of this really cool stuff, but all from my editor without having to run extra tools and do all that work is fantastic. Okay. So type providers, they really provide an integrated solution for accessing data sources, integrated into the language, where instead of generating source code that my compiler then compiles, I instead tell the compiler, hey, know about these types. Okay. We already said it keeps the experience code focused, and it provides this uniform programming experience. And schema change integrates into the IDE and the build system. We saw that when I didn't have a URL there, and we saw, hey, there's squiggles. The same thing would happen if the schema changed, as we said. Now, honestly, there's still a problem, right? And that problem is that what if the schema changes after I've compiled? That is a very, very hard problem to solve. That is something that this solution does not go after. It is something that hopefully we'll solve at some point, but that's a very, very hard problem to solve. So I know a lot of you kind of self-selected and said, hey, I'm really curious about F Sharp. I'd like to learn a little bit about it. I hope I showed you enough of that to kind of get you excited, get you interested. F Sharp 3.0 is in Visual Studio 2012 RC, which you can download. There's a tutorial project type in Visual Studio 2012 where you say new project, Visual Studio or Visual F Sharp, F Sharp tutorial. Actually, were anybody at my tips and tricks talk this morning? No? Yes? Yes? Control-Shift-N, Control-E, F-Sharp tutorial, tab, enter. Okay? So you can learn the language. I mean, it's just got this really great kind of tutorial to walk through some of the language concepts. And for more information, check out fsharp.net. All right? So, and the last piece I want to mention is just, hey, the cloud wasn't so bad today. Please take some time and submit the evals. It helps me out. And you guys have been an awesome audience. Are there any questions? You first. Yes. So the question was that we did the GUI portion in C# and the program logic in F#. Why not do everything in F#? Well, in some cases, the F# is focused very much on this compute problem, and the support for all of the designers and the platforms isn't there for F#. So it is much more convenient in a lot of cases to use the other languages to write it. I personally have written a lot of model view model WPF applications exclusively in F# without using C# and VB and found it to be delightful. So you can do that. You'll run into some challenges with it, but it is possible. And there are people out there that are, if you search around on the web, you'll find some guys like Chris Marinos and some of those guys that are actually playing with doing that for various different application types. But out of the box, the designers aren't supported, so that's the key reason. And you had a question, right? Yes, you. So type providers, does it have something to do with the dynamic type? No. It does not have something to do with the dynamic type. So the dynamic type, I mean, you could think it does. You could think so in a way that it does, but it really doesn't. You could do these sorts of things with dynamic. Obviously, you could write dynamic objects and idynamic meta object providers, IDMOPs, I think we call them. That actually encapsulate some of the same freebase logic. The trick, though, is that it's statically typed, and you get type checking. And that's where it's very different from dynamic. Whereas dynamic, I wouldn't get type checking because that all happens at runtime. Mm-hmm. Yep. You can absolutely do that today with dynamic. You can absolutely do what you're thinking today with dynamic. But you don't get the IntelliSense. This is a way that we talked about as a potential way to get dynamic IntelliSense at some point, sort of dynamic IntelliSense. But it really doesn't use the dynamic infrastructure. It doesn't use any of the DLR's infrastructure. It's literally simply static types that we're pushing into the type checker, and those actually get erased at compile time, right? So kind of the GUI to do the hookup with freebase and all that, some of that actually gets pushed in. At compile time and baked into your application. So it's a little bit different than what you're thinking with dynamic. It's it's somewhat related, you know, and that we're calling into things that we don't really know about, right? But it is a bit different. Does that answer your question at all, or is it still confusing? Why not? Why not is partly the why not. I would say I would argue that F# is not really about doing dynamic and doesn't have the dynamic type specifically. It does have some kind of support for that. That's very light support for doing dynamic stuff, but really that would be a C# thing or a VB thing with late binding. Say one more time. Mm-hmm. Well, that's one piece of it, right? So the question is the type provider, it executes inside Visual Studio to provide IntelliSense. That's one piece of it, but it also executes at compile time, right? So, and then there's kind of a runtime piece there too as well. So, but it tries to pull those runtime pieces into your application, erasing the types. Yeah. Is it possible to do it online, offline? I believe it is. I have not found the way. I've struggled with that myself because of the internet being down today. But I believe it is possible to cache some of these things. You know what? How about if you want to find out the answer, give me your card and I'll hook back with the F# team and we'll talk about it and kind of figure out what the solution is there. Because I saw another hand. Yeah. Mm-hmm. Okay.
I would like to say coding the code eventually. I don't know. How does it work?
How does that work? I think that's kind of up to the person that implements the type provider to say, I'm going to provide some sort of way for you to do that logging, to do that tracing. I'm not actually sure if that's in there for the ones that we're shipping out of the box to understand that. But you do get exceptions bubbled back to you when things do go wrong, so you can handle them, you know, as you would normally handle exceptions. But because those would generally be exceptional cases, right? So, yes, your question about, I mean, at its core is like, how do I debug this, right? And yeah, it's a hard problem to solve. It's a hard problem to solve, right? Yes, after the fact. I don't have a great answer for you right now. That's partly because I'm the F# fanboy guy and not on the F# team. But again, I want both your cards, and I'll check with the F# team. We can sync back up and get some answers to those questions. Some good answers, solid answers. Yeah. Is there any reason why we wouldn't see C# type providers? Gosh, it's right now we are very focused on delivering async, and that's kind of in the future, right? So at the moment, we're not really thinking too much about future language features. There's some discussion about it, but it is something that's on the list because what I really like about type providers is it's kind of the other side of the link coin, right? Link gives you query, and F# is how you get the data, right? Or the type providers are how you get the data. So it's an interesting idea. It's not something that we have plans for right now, though. You had one, yes. Will there be GPU support for F#? I don't know. I do not know. I know that Tomasz Petracek did a blog series where he showed how to do some cool GPU stuff with F#, building a library using the computation expression infrastructure, which is nifty, and you can search for Tomasz Petracek and GPU and find some of that information. It's kind of cool, but yeah. Would it be possible to use F# to just do a general Visual Studio extensions to improve IntelliSense? Unfortunately, no. F# right now, that design time experience of the IntelliSense and type providers extending that is baked very much into the F# IntelliSense implementation. And so it wouldn't impact like the other languages. So you wouldn't be able to use type providers to improve C# or Visual Basic or anything like that. if you're interested in doing that sort of thing, I am providing extensibility points for the completion list for C# and Visual Basic in Roslyn, so with Project Roslyn, so that you can do that sort of thing. And I'm hoping that when I put it out there, that somebody will go and do the dynamic IntelliSense that he was looking for. So, yeah, last question. Pretty rock and roll. I like that. F# pretty rock and roll. I just want to make sure that's on the recording.
I'm really interested to see how we can make money with it in the enterprise.
Mm-hmm.
Because rock and roll alone is rock and roll. Cause some of the problems were raised about debugging and
Sure.
handling, even the fact that it's just an entry type of language. How do you see it progressing with an enterprise, and how do you see it being integrated into enterprise apps, and when do you see the value point coming to life?
So it is being used in the enterprise, right? It's especially being used in these domains where there's lots of number crunching computation that I talked about earlier. But that program logic will live in F#. So, a lot of financial companies have taken F# and said, well, I can write my code and I can put units of measure on here, and I can see the errors. You've solved bugs for us simply by us moving it over to F#. So there are companies using that. As a general purpose kind of enterprise application thing where you're doing business applications, that's really where I see it living. I see it living in the place where you do your business rules, where where I showed the Project Euler demo, how you could just very succinctly state the algorithm, that in just kind of an elegant, beautiful way, in a rock and roll sort of way, and then building your application around that. Does that sort of answer your question? The debugging experience is not bad. The debugging experience actually is, it's a .NET language, so it uses the managed debugger. I didn't want to give the implication that debugging is just like falling over. It's not falling over at all. IntelliTrace is there. All of the debugging features of Visual Studio work on F#. Right? So you have debugging. It's just the problem of, okay, how do I detect why my design time IntelliSense failed? Right? That's the hard problem to debug. But you can see the problems at runtime.
No, that's good stuff.
Okay.
Pushing me in that way, then.
Yes. All right. Well, that's all the time we got. So I thank you guys for hanging in there.